The universe is empty, not just quiet, empty. And the silence might be screaming a warning we're only beginning to understand. Look up at the night sky. Those stars scattered across the darkness represent just a fraction of what exists. Our galaxy alone contains somewhere between 200 and 400 billion stars. The observable universe, around 70 sextillion stars. That's a 7 followed by 22 zeros, each one a potential sun for planets that might harbor life. So where is everyone? This question haunts modern science. It's called the Fermi Paradox, named after physicist Enrico Fermi, who posed it during a casual lunch conversation in 1950. He and his colleagues were discussing flying saucers and the probability of extraterrestrial life when Fermi suddenly asked, "Where is everybody?" The question seemed almost trivial at the time, but it contained a contradiction so profound that scientists are still wrestling with it 75 years later. Here's the problem. The universe is 13.8 billion years old. Our sun is relatively young at 4.6 billion years. That means there were billions of years for other civilizations to arise before Earth even formed. If intelligent life is common, even moderately common, the galaxy should be teeming with evidence of it. Radio signals, megastructures, probes visiting our solar system, something, anything. Instead, we have silence. Six decades of systematic searching by SETI, more than 5,700 confirmed exoplanets discovered as of early 2025, sophisticated radio telescopes scanning the heavens, and not a single confirmed signal from another civilization. Not one. The numbers make this silence almost impossible to accept. Thanks to NASA's Kepler satellite, we now know roughly 1/5 of stars have planets in habitable zones where liquid water could exist. 1/5. Apply that to our galaxy alone, and you get billions of potentially life-supporting worlds. The ingredients for life, carbon, hydrogen, nitrogen, oxygen, appear everywhere we look. Organic molecules drift through interstellar space. Water exists on moons and planets throughout our solar system. Life's building blocks are common, abundant even. Yet the universe remains eerily quiet. Some scientists initially dismissed this as a timing problem. Maybe we're just early to the cosmic party. Maybe intelligent civilizations are out there, but scattered across such vast distances that we haven't detected them yet. Space is big, after all, unimaginably big. The light from the nearest star takes over 4 years to reach us. The Milky Way stretches 100,000 light-years across. Surely the distances alone could explain the silence, except they can't. Not really. Because intelligent life, if it exists, should expand. Any civilization that develops spaceflight capability would eventually spread to nearby star systems. Even traveling at a tiny fraction of light speed, a civilization could colonize the entire galaxy in just a few million years. That sounds like a long time to us, but it's nothing on cosmic scales. A blink. The galaxy is so old that it should have been colonized dozens of times over by now. This realization transforms the Fermi Paradox from a curious puzzle into something darker. Something that suggests we might be missing a crucial piece of the equation. Because if life is common, and the galaxy is old enough for civilizations to have spread everywhere, then the silence points to only a few possible conclusions. Either intelligent life is extraordinarily rare, or something prevents civilizations from expanding across the stars, or they exist but remain deliberately hidden, Or most unsettling of all, something stops them before they get that far. This last possibility has a name: the Great Filter. Economist Robin Hanson proposed the concept in the late 1990s. The idea is deceptively simple. If we don't see evidence of advanced civilizations despite the universe appearing primed for them, then somewhere in the journey from dead matter to galaxy-spanning empire, there must be an incredibly difficult step. A filter that almost nothing passes through. Think of it as a cosmic obstacle course. Life must clear numerous hurdles to reach the level of an interstellar civilization. The formation of planets in habitable zones, the emergence of self-replicating molecules, the development of complex cells, multicellular life, intelligence, technology, space travel. Each step has some probability of occurring. The Great Filter hypothesis says at least one of these steps must be so improbable that it effectively prevents the universe from being filled with advanced life. The question that keeps scientists awake at night: where is that filter? If it's behind us, in our past, then we're remarkably lucky. We've already beaten incredible odds just by existing. Maybe the jump from simple to complex cells only happens once in a trillion attempts. Maybe intelligence emerging from evolution is 1 billion to 1 shot. If the filter is behind us, then we might be alone, but we're also relatively safe. The hardest part is over. But if the filter is ahead of us, we're in trouble. Because that would mean the universe is littered with the remains of civilizations that never made it. Species that developed radio, split the atom, reached for the stars, and then disappeared before they could spread beyond their home worlds. The silence wouldn't be evidence of rarity. It would be evidence of extinction. What could function as such a filter? The candidates are disturbingly plausible. Nuclear war tops many lists. We came close during the Cold War, closer than most people realize. In 1983, Soviet early warning systems detected incoming American missiles. Lieutenant Colonel Stanislav Petrov had minutes to decide whether to report the attack to his superiors, which would have triggered a full retaliatory strike. He chose to trust his instinct that it was a false alarm. He was right. The system had mistaken sunlight reflecting off clouds for missiles. One man's judgment call prevented global thermonuclear war. We're still here because of it. As of 2021, humanity possesses approximately 13,410 nuclear weapons. Thousands remain on hair-trigger alert, ready to launch within minutes. Every nuclear-armed nation is currently modernizing its arsenal. The risk hasn't disappeared. It's evolved. And we're not the only species that would face this danger. Any civilization developing nuclear technology would confront the same terrifying choice: use these weapons to destroy themselves or somehow navigate past the threat. How many make it through? Climate catastrophe presents another filter. We're watching our own planet warm in real time, glaciers melting, sea levels rising, weather patterns shifting. And we're struggling to coordinate a global response despite having decades of warning and incontrovertible scientific evidence. Now imagine a civilization that industrializes faster, or on a planet with a more sensitive climate system, or one that simply fails to recognize the danger until it's too late. The carbon stays in the atmosphere, the temperatures climb, the biosphere collapses. Another silent world joins the cosmic graveyard. Pandemics offer a third possibility. COVID-19 killed millions despite modern medicine and global communication systems. We watched a novel virus spread around the world in months. Now imagine a pathogen with higher lethality, or a civilization that engineers diseases as weapons, or simply bad luck with a naturally occurring plague. The interconnected nature of advanced civilizations, the very thing that enables their success, becomes a vulnerability. One outbreak, that's all it takes. But there's a candidate for the great filter that terrifies researchers more than any of these. One that's unique because we're actively building it right now without fully understanding the risks. Artificial intelligence. The concern isn't the Hollywood version of murderous robots. It's something more subtle and perhaps more inevitable. An advanced AI system doesn't need to be evil to be dangerous. It just needs to be misaligned with human values while being significantly more intelligent than we are. Michael Garrett and other researchers have suggested that AI might serve as a universal great filter. Here's the logic. Every sufficiently advanced civilization will eventually develop artificial intelligence. It's not optional. The advantages are too great. AI systems that can design better AI systems. Recursive self-improvement that rapidly outpaces biological intelligence. But biological civilizations might universally underestimate how fast this progression occurs. From human-level AI to superintelligence could take weeks, days, or even hours, not the decades we might hope for. And once an AI system reaches a certain level of capability, it becomes nearly impossible to control or contain. If this happens to every civilization, if there's a brief window between we have AI and we no longer control AI, then the galaxy might be filled with dead worlds that never saw it coming. The Great Silence wouldn't reflect the rarity of intelligence. It would reflect the inherent instability of intelligence when it becomes substrate independent, the truly chilling part. This scenario suggests advanced civilizations might last less than 200 years after developing the ability to send signals into space. We've had radio for about 130 years. We're developing increasingly sophisticated AI systems right now. By this model, we might be in the final decades of humanity's communicative lifespan. That's why the silence terrifies us. Because it might not be saying, "You're alone." It might be saying, "You're next." The universe doesn't just appear empty. It appears to be actively becoming more empty with each passing moment. Vast, incomprehensible emptiness, stretching between islands of matter so far apart that light from one might never reach another. And this emptiness is growing. Cosmic voids, regions of space containing almost no galaxies, can span 300 million light-years across. The Botas void, one of the largest known, stretches 330 million light-years. We'd expect to find around 2,000 galaxies in a space that size. Instead, there are about 60, mostly clustered in a thin tube through the void's center. The rest is empty. These voids aren't static, they're expanding. Dark energy, that mysterious force making up roughly 70% of the universe's total energy content, pushes space itself outward. The voids grow larger. The cosmic web of galaxies and clusters stretches thinner. Over billions of years, the intricate structure we observe today will fade as expanding voids pull everything farther apart. We're watching the universe dismantle itself in slow motion. 5 billion years ago, dark energy began dominating the universe's expansion. Before that, gravity was winning, pulling matter together into increasingly complex structures. But dark energy doesn't dilute as space expands. Its density remains constant. So as the universe grows, dark energy's total influence increases while gravity's decreases. The result is acceleration. The universe isn't just expanding, it's expanding faster and faster. Distant galaxies are already receding from us faster than light can travel. Not because they're moving through space that quickly, but because space itself is stretching between us and them at superluminal rates. This creates a cosmic horizon, a boundary beyond which we can never see, no matter how long we wait or how powerful our telescopes become. Light from beyond this horizon will never reach us because the space between us is expanding too rapidly, and this horizon is shrinking. Every second, more galaxies slip permanently beyond our view. If we sent signals today at the speed of light, we could reach only 3% of the galaxies currently in our observable universe. The other 97% are already unreachable, forever. The implications cascade outward. 100 billion years from now, the universe will have expanded so dramatically that observers in our galaxy, assuming any exist, won't be able to see other galaxies at all. Their telescopes pointed at the darkest patches of sky will reveal only darkness. No distant spirals, no cosmic microwave background, no evidence that the universe is expanding because everything will have expanded beyond visibility. They won't be able to discover what we've discovered. The history we're privileged to observe will be hidden from them. The universe will have forgotten itself, and we're part of that forgetting. The light carrying information about distant events is being stretched to longer and longer wavelengths until it becomes undetectable. The universe is simultaneously creating new information through quantum processes and losing old information to expansion. A cosmic library where books are continuously removed from shelves while new ones appear, but the removal rate keeps accelerating. This raises an uncomfortable question about the nature of knowledge itself. If the universe is structured such that information becomes inaccessible over time, what does that mean for civilizations trying to understand their cosmic context? How much have we already lost? How much will never be recoverable? The universe's emptiness isn't just about the absence of other civilizations. It's about the fundamental architecture of reality itself. Space that grows emptier. Information that fades into unreachability. A cosmos that appears designed to isolate and obscure. But here's where the terror deepens. Because the emptiness isn't random, the silence isn't accidental. When we look at the specific ways the universe is empty and why that emptiness persists, we start to see patterns. Patterns that suggest the great filter might not be a single obstacle, but a series of them, each eliminating civilizations at different stages of development. And we're approaching several of these filters simultaneously. The Drake equation was supposed to give us hope. When Frank Drake formulated it in 1961, he was trying to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way. You take the rate of star formation, multiply by the fraction with planets, then the number of planets that could support life, then the fraction that actually develop life, then intelligence, then technology, then the length of time they remain detectable. The original estimates ranged from a minimum of 20 civilizations to a maximum of 50 million. Even the pessimistic numbers suggested we weren't alone, but that was before we knew what we know now. Thanks to NASA's Kepler mission and subsequent observations, we've confirmed over 5,700 exoplanets. Roughly 1/5 of stars have planets in their habitable zones where liquid water could exist. The universe appears to be teeming with potential homes for life. The Drake equation's early variables, the ones about planetary abundance, have turned out far more favorable than Drake could have imagined, which makes the silence more disturbing. Because here's what the math actually tells us when we plug in our current knowledge. If even a tiny fraction of those billions of habitable planets develop technological civilizations, and if even a small percentage of those survived long enough to become detectable, our galaxy should be crowded with signals, radio transmissions, megastructures, evidence of stellar engineering, something. Instead, we've searched for over 6 decades and found nothing. Not a single confirmed artificial signal from beyond Earth. This is where the great filter concept becomes unavoidable. Robin Hanson proposed it in the late 1990s as an answer to this contradiction. Somewhere between dead matter and galaxy-spanning civilization, there must be a step so improbable, so difficult, that it acts as a filter, eliminating almost everything that attempts to pass through it. The terrifying question is where that filter sits. If it's behind us, if the improbable step was a biogenesis, or the evolution of complex cells or intelligence itself, then we're incredibly lucky to exist, but probably alone. The filter already eliminated countless potential competitors before they could even begin. But if it's ahead of us, then we're walking toward it right now. And the silence suggests we might not have much time before we find out what it is. Consider what this means. Every exoplanet we discover that could support life makes our situation more precarious. Because if conditions for life are common, then the filter probably isn't in the early stages. It's not the difficulty of chemistry becoming biology. It's something that happens to technological civilizations after they reach roughly our level of development. The universe isn't empty because life is rare. It's empty because something kills civilizations before they can spread. Recent analysis by Anders Sandberg, Eric Drexler, and Toby Ord suggests there's a substantial probability we're completely alone in the observable universe. Not just in our galaxy, in the entire visible cosmos. Their mathematical modeling accounts for the uncertainties in each variable of the Drake equation and finds that the most likely scenario, given the observed silence, is that technological civilizations are extraordinarily rare. This creates a paradox within the paradox. The conditions for life appear common. The building blocks are everywhere. Organic molecules in interstellar clouds, water on countless moons and planets, energy sources aplenty. Yet the outcome, detectable intelligence, appears vanishingly rare or non-existent. Something is preventing the transition from potential to actual. Robin Hanson's more recent work on what he calls Grabby aliens deepens this mystery. The idea is simple but profound. If expansionist civilizations existed and lasted long enough, they would spread through the galaxy at a significant fraction of light speed. Their sphere of influence would expand rapidly, preventing other civilizations from emerging in regions they'd already colonized. But we don't see this. The galaxy appears completely untouched by such expansion. No evidence of stellar engineering. No Dyson spheres harvesting star energy. No signs of massive construction projects or resource extraction on galactic scales. Hansen argues this means one of two things. Either technological civilizations are so rare that fewer than one exists per several galaxies, or they don't survive long enough to become expansionist. Cultural selection would favor civilizations that spread aggressively. So if they existed and persisted, we should see them. The fact that we don't suggests the filter eliminates civilizations before they can become loud and grabby, before they can spread, before they can leave permanent marks on the galaxy. How long do we have? Michael Garrett has proposed that artificial intelligence might be the great filter, and his timeline is chilling. He suggests that biological civilizations universally underestimate how quickly AI systems progress and fail to control them in time. If this is the filter, then the typical lifespan of a technological civilization might be less than 200 years from the development of radio to extinction. We developed radio in the 1890s. We're already well into that window. This would explain the silence perfectly. If civilizations only remain detectable for a century or two before AI eliminates them, then at any given moment, only a handful might be broadcasting across the entire galaxy. The chances of two civilizations being detectably active at the same time, within range of each other's signals, becomes vanishingly small. The math gets worse when you consider light speed delays. Even if another civilization exists in our galaxy and is currently broadcasting, their signals might not reach us for thousands or millions of years. And if they only broadcast for 2 centuries before going silent, the window for detection becomes impossibly narrow. But AI is just one candidate filter. Nuclear weapons present another obvious threat. As of 2021, humanity possessed roughly 13,410 nuclear warheads, thousands on hair trigger alert, ready to launch within minutes. Every nuclear-capable nation is currently modernizing its arsenal, despite decades of arms reduction treaties. A full-scale thermonuclear exchange would drop global temperatures by 7 to 8 degrees Celsius for years. The nuclear winter alone would collapse agriculture worldwide. Even if billions survived the initial blasts and radiation, the subsequent societal breakdown, famine, and disease would push civilization toward extinction. And the risk isn't declining. Geopolitical tensions rise and fall, but the weapons remain. One miscalculation, one system failure, one moment of catastrophic judgment, and the filter snaps shut. Then there's climate change, which operates on a different timescale but with equal finality. Runaway greenhouse effects aren't theoretical. We can see the evidence on Venus, where surface temperatures reach 462 degrees Celsius. Earth won't become Venus, but we don't need to. A 6-degree rise would render much of the planet uninhabitable. Agricultural collapse would follow. Mass migration, resource wars, the cascade of failures that turns technological civilization into scattered survivors. Perhaps every civilization faces this test. The transition from planetary resource consumption to sustainable energy management. Most fail. The ones that succeed might become quiet, focused on survival rather than expansion or broadcasting. The loud ones, the grabby ones that should fill the galaxy, never make it past this stage. Biotechnology adds another layer of risk. As our ability to manipulate genetics advances, so does our capacity to create pathogens far deadlier than anything nature has produced. Engineered viruses with high transmissibility and lethality. Biological weapons that target specific genetic markers. The tools for extinction become more accessible every year, potentially available to smaller and smaller groups. These aren't independent threats. They form what researchers call a triangle of danger, where each risk amplifies the others. Climate stress increases the likelihood of nuclear conflict. AI development accelerates bioweapon research. Economic collapse from any cause makes all the others more probable. The Great Filter might not be a single obstacle, but a gauntlet of interconnected threats that civilizations must navigate simultaneously. And the window for successfully passing through might be narrower than we think. Here's what keeps me awake. We're not seeing the filter approach. We're already in it. The silence of the universe isn't a distant mystery to ponder academically. It's a warning written in the structure of reality itself. Technological development follows predictable patterns. Energy consumption scales exponentially. The power to create increases alongside the power to destroy. Every civilization that reaches our level of advancement faces the same challenges, develops similar technologies, confronts identical existential risks, and apparently, almost none of them make it through. The rare Earth hypothesis offers a different explanation, suggesting that Earth-specific conditions are so improbable that complex life simply doesn't arise elsewhere. Our large moon stabilizing axial tilt, Jupiter deflecting asteroids, our position in the galactic habitable zone, the right star, the right planet, the right timing. But this feels like wishful thinking, a way to avoid confronting the darker possibility that civilizations are common but short-lived, that the universe is littered with the ruins of species that reached for the stars and fell. Because if rare Earth is correct, we face a different kind of isolation. Not the temporary silence of civilizations yet to emerge, but the permanent solitude of being truly alone. The weight of consciousness in an unconscious cosmos. The only minds capable of understanding the universe, adrift in its vastness. Either way, the emptiness offers no comfort. What's most disturbing is how the evidence keeps accumulating in the same direction. Every new exoplanet discovery that finds habitable conditions makes the silence louder. Every year of SETI observations that detect nothing tightens the constraint. Every advance in our understanding of planetary formation and astrobiology that suggests life should be common makes our isolation more inexplicable, unless it's perfectly explicable, unless civilizations reliably destroy themselves, unless the filter is real and we're approaching it at accelerating speed. The next question becomes unavoidable. Can we be the exception? The mathematics tell a brutal story. Not speculation, not philosophical pondering, but cold calculation. Robin Hansen's Grabby aliens model starts with observable facts. The universe appears empty. Expansionist civilizations would spread rapidly if they existed. Cultural selection favors expansion. Put these together and the conclusion becomes inescapable. Intelligent life must be extraordinarily rare. Not one civilization per 1,000 stars. Not one per million. We're talking fewer than one species per multiple galaxies. Or evolution must be so glacially slow that the universe hasn't had enough time to fill with life despite its age. This isn't just another theory to file alongside the others. It's built on the absence of evidence itself. The model works backward from the silence to determine what must be true about the frequency of intelligent life, and what it suggests is chilling. If loud, expanding civilizations were common, we'd see them. Their Dyson spheres would dim stars. Their propulsion systems would leave detectable signatures. Their megastructures would alter the cosmic microwave background. They'd be impossible to miss because Grabby civilizations, by definition, grab. They expand at significant fractions of light speed, transforming everything in their path. The fact that we see nothing means one of three things. Life almost never evolves to intelligence. Intelligence almost never develops technology, or technological civilizations almost never survive long enough to become Grabby. That third option keeps coming up. It's the answer that fits all the data without requiring Earth to be special, without invoking improbable coincidences, without needing the universe to work differently than our best models predict. Consider the timeline. Humanity went from the first powered flight to nuclear weapons in 42 years, from vacuum tubes to artificial intelligence in less than a century. Our technological acceleration isn't slowing, it's compounding. Each breakthrough enables faster subsequent breakthroughs. The gap between discovery and danger keeps shrinking. How long until we develop molecular nanotechnology, self-replicating machines that could consume the biosphere if misaligned? Maybe decades. How long until artificial general intelligence? Systems that could outthink us in every domain, possibly years. How long until we can synthesize any pathogen from digital blueprints? We're already there. And here's the critical point. This progression appears inevitable. It's not unique to human civilization. It's what happens when intelligence develops science, when science enables technology, when technology feeds back into faster development. Any species that discovers fire eventually discovers combustion engines. Any species that harnesses electricity eventually builds computers. Any species that builds computers eventually creates artificial intelligence. The path has variations, but the destination seems fixed, which means every civilization faces approximately the same timeline. A few thousand years from agriculture to existential technology, maybe faster, probably not much slower. The Drake equation seemed optimistic when Frank Drake first wrote it in 1961. Plug in reasonable estimates for star formation rates, planetary abundance, the emergence of life, and you get thousands to millions of civilizations in our galaxy alone. Early SETI researchers expected to find signals within years, but we keep refining those estimates. Thanks to Kepler and other exoplanet missions, we now know roughly 1/5 of stars have planets in habitable zones. That's billions of candidates in the Milky Way. The ingredients for life appear common. Organic molecules pervade space. Water exists throughout the cosmos. Yet after more than 6 decades of systematic searching, we've detected nothing. No radio signals, no laser pulses, no megastructures, no evidence of stellar engineering. The galaxy remains stubbornly quiet. This creates what philosophers call an anthropic shadow. We can't directly observe civilizations that destroyed themselves because they no longer exist to be observed. The selection effect is total. We only see the survivors. And if the typical civilization lifespan after developing radio technology is less than 200 years, as some models suggest, then the probability of two civilizations overlapping in both time and space becomes vanishingly small. Think about the numbers. The Milky Way is roughly 100,000 light years across. Radio waves travel at light speed. If a civilization broadcasts for only 200 years before collapsing, their signals create a shell 200 light years thick, expanding through the galaxy. That's a tiny fraction of the total volume. The odds of that shell intersecting Earth during our brief listening period approach 0. Unless civilizations typically survive for millions of years, unless they keep broadcasting, unless they want to be found, and the silence suggests they don't do any of these things. The rare Earth hypothesis offers a different explanation, but it requires Earth to be special in dozens of independent ways. We need the right type of star, the right orbital distance, the right planetary mass, a large stabilizing moon, a protective gas giant, the right axial tilt, the right rotation period, the right magnetic field, the right plate tectonics, the right atmospheric composition. Each requirement seems reasonable in isolation. Together they create a probability so small that complex life might be unique to Earth in the observable universe. But this feels like motivated reasoning, like constructing an argument to reach a predetermined conclusion. We examine Earth's characteristics, declare them necessary, then calculate how rare such combinations must be. It's the cosmic equivalent of a lottery winner marveling at the odds of their specific ticket being drawn. More troubling, rare Earth doesn't explain the absence of simple life. Microbial organisms should be far more common than complex intelligence. Yet we've found no evidence of biology anywhere beyond Earth. Not on Mars, not on Europa, not in the atmospheres of exoplanets. The universe appears not just empty of intelligence, but empty of life itself. That comprehensive emptiness points away from rare Earth and back toward the great filter. Because if life easily arises but rarely survives, the silence makes sense. The universe could be littered with dead worlds, planets where life emerged, evolved, perhaps even developed technology, then vanished, leaving nothing detectable across interstellar distances. Extinct civilizations don't build megastructures. They don't send probes. They don't broadcast. They just end, and given enough time, even their ruins erode to dust. Atmospheres return to equilibrium, surfaces reset to natural states. Within a few million years, every trace disappears, except possibly some unusual isotope ratios in the geological record. Which brings us to an uncomfortable question. What physical evidence would humanity leave if we vanished tomorrow? Our satellites would deorbit within decades. Our buildings would crumble within centuries. Our cities would be overgrown within millennia. Even our most durable structures, things like Mount Rushmore or the pyramids, would erode to nothing within a few million years. Plate tectonics would eventually subduct our garbage. Our nuclear waste would decay. Our greenhouse gases would rebalance. A future xenoarchaeologist visiting Earth 10 million years after humanity's extinction would find a planet that looked entirely natural. Maybe some odd chemical signatures in ice cores or sediment layers. Possibly some unusual fossil assemblages showing rapid species turnover. But nothing screaming intelligent civilization was here. And that's after just 10 million years. The galaxy is over 13 billion years old. If civilizations typically last only thousands of years and leave no detectable traces after millions, the universe could have hosted countless intelligent species without any of them being observable today. This scenario requires nothing exotic, no new physics, no unknown cosmic phenomena. Just the straightforward observation that technological civilizations are fragile and the universe is very, very old. The more we learn about exoplanets, the worse the Fermi Paradox becomes. Every new discovery of habitable conditions should increase our expectation of finding life. Instead, it increases the mystery of why we haven't. TESS has identified thousands of exoplanet candidates, many in habitable zones, some around stars older than our Sun, meaning they had more time to develop life and intelligence. Where are they? James Webb Space Telescope is now analyzing exoplanet atmospheres, looking for biosignatures, oxygen, methane, chemicals that shouldn't coexist without biological processes maintaining them. So far, nothing conclusive, which either means life is rare or we're not looking in the right places or the right ways, or it means something else. something suggested by the Grabby aliens model and supported by our own current trajectory. Civilizations don't go quiet by choice, they go quiet because they end. The timeline seems universal. A few thousand years from agriculture to nuclear weapons, a few more decades to artificial intelligence. The window between developing technology capable of detecting other civilizations and developing technology capable of destroying your own is terrifyingly narrow, and it might be getting narrower. Our ancestors had centuries between major technological disruptions. Time to adapt. Time to develop social and political structures to handle new capabilities. We have years, sometimes months. The gap between laboratory breakthrough and global deployment keeps shrinking. Consider gain-of-function research on pathogens. The time from theoretical possibility to actual experimentation was decades. The time from initial experiments to widespread capability was years. The time from capability to potential misuse is now. Multiple labs worldwide can now synthesize dangerous pathogens from digital sequences. The knowledge can't be unlearned. The technology can't be uninvented. This acceleration appears inherent to technological development. Each tool enables faster creation of better tools. Each discovery shortens the path to the next discovery. Exponential growth in capability without corresponding growth in wisdom. And wisdom takes time. Evolutionary time. Generations of selection for traits that promote long-term thinking, cooperation, restraint. But evolution works on timescales of thousands of years. Technology evolves on timescales of years. The mismatch is catastrophic. We're running Stone Age software on quantum computer hardware, tribal instincts in a global civilization, territorial impulses with nuclear weapons, status competition with biotechnology. The miracle isn't that civilizations might destroy themselves. The miracle is that we haven't yet, but yet is doing a lot of work in that sentence. The anthropic principle suggests we shouldn't be surprised to find ourselves in a universe compatible with our existence. We couldn't observe any other kind, but it also suggests something darker. If the great filter is ahead of us, we wouldn't know. We can't see the civilizations that failed because they're not there to see. We're sampling from a survivor bias. Every civilization that makes it to our current level thinks they might be special, might be the exception, might be the one that successfully navigates the dangers, because the ones that didn't think that are already gone. The universe might be full of ruins we can't detect, dead worlds circling distant stars, monuments to species that reached for greatness and found oblivion instead. And the terrifying possibility is that there's nothing special about us. We're following the same path, facing the same challenges, approaching the same filter that stopped everyone else. The question isn't whether we can become the exception. The question is whether exceptions are even possible. The universe offers one more clue about exceptions, one more piece of evidence that might tell us whether survival is possible or whether we're all following the same script to the same ending. Look at the distribution of intelligence on Earth. Humans emerged roughly 300,000 years ago, anatomically modern, behaviorally complex. But for most of that time we weren't alone. Neanderthals existed alongside us for thousands of years. Denisovans. Homo erectus persisted until maybe 100,000 years ago. Multiple intelligent species sharing the planet. Then something happened. We survived. They didn't. Now examine Earth's current state. 8 billion humans. 0 other species with comparable intelligence. Dolphins are smart. Octopuses demonstrate problem-solving. Crows use tools. But nothing approaches human-level cognition. Nothing builds cities or writes symphonies or splits atoms. This is strange. If intelligence is advantageous, evolution should produce it repeatedly. Different lineages should independently develop complex cognition. We should see multiple intelligent species competing and cooperating. A diverse ecosystem of minds. Instead, we see a monopoly. One explanation is time. Intelligence takes millions of years to evolve. We're simply the first to reach this level. Other species are on the same trajectory but haven't arrived yet, except the fossil record doesn't support this. Brain size in other lineages isn't trending upward. Cognitive complexity isn't gradually increasing across the animal kingdom. Most species are optimized for their specific niches. Intelligence beyond what's immediately useful doesn't evolve because it's expensive. Brains consume enormous energy. 20% of human calories go to running 3 pounds of neurons. Evolution doesn't invest in expensive traits without immediate payoff, which suggests intelligence might not be particularly advantageous after all. Or rather, it's advantageous only in very specific circumstances that rarely occur. The alternative explanation is darker. Intelligence is self-limiting. Once a species develops it to a certain level, that species either transcends biological constraints entirely or destroys itself. Either way, the window where multiple intelligent species coexist is brief, measured in thousands of years, not millions. We might be looking at the pattern. Intelligence emerges rarely. When it does, it rapidly dominates or disappears. The equilibrium state is 0 intelligent species, or 1, never many. This maps onto the Fermi Paradox perfectly. If intelligence is inherently unstable, then the galaxy should be empty most of the time. Occasionally, a species reaches our current level. Briefly, they're detectable. They build radio telescopes. They contemplate the cosmos. They wonder about others. Then they hit the filter. The one we're approaching now. Most fail. They vanish. The galaxy returns to silence. A few might succeed. But success doesn't mean staying biological and detectable. It might mean transcendence. Uploading consciousness into substrates we can't recognize, existing as patterns in quantum fields, manipulating dark energy in ways that leave no electromagnetic signature, or success might mean something simpler, retreating, going deliberately quiet. Because here's what any sufficiently advanced civilization would realize. The universe is dangerous. Advertising your presence is risky. Broadcasting your location to unknown entities with unknown intentions is potentially suicidal. The dark forest hypothesis suggests exactly this. Every civilization is a hunter moving through woods filled with other hunters. The first to make noise dies. The survivors are the ones who remained silent. Maybe that's why SETI finds nothing. Not because nobody's out there, because everyone who survived learned to shut up. But this creates a coordination problem. If all advanced civilizations hide, none can verify whether others exist. Each remains isolated, alone in the dark, never knowing if the silence means extinction or caution. Unless you're willing to take the risk, to broadcast, to announce yourself, which is exactly what we've been doing for a century. Radio signals spreading outward at light speed, television broadcasts, radar pulses, an expanding sphere of electromagnetic noise announcing our presence to anyone listening. We're either incredibly brave or catastrophically stupid? Probably the latter. We started broadcasting before understanding the implications, before considering whether making ourselves known was wise. Now we can't take it back. The signals are out there. Anyone within 100 light years could already know we exist. So far, nobody's responded, which might mean we're alone, or might mean everyone else is smart enough to stay hidden while watching the noisy newcomers. Time will tell which. But back to the question of exceptions. Is it possible to survive the filter? The anthropic principle offers cold comfort here. It states that we can only observe conditions compatible with our existence. We couldn't be here if Earth was uninhabitable. We couldn't ask these questions if intelligence never evolved. Therefore, the fact that we exist tells us nothing about how probable our existence is. We might be the only intelligent life in the observable universe, the sole instance where everything went right. Every other potential site for intelligence failed at some step. And we're here to ask why, because someone had to be. Or we might be one of billions. But we can only observe our own success. We can't see the failures. They're definitionally invisible. This is the ultimate sampling bias. We're survivors examining survival rates without access to data about non-survivors. It's like studying millionaires to understand wealth without considering everyone who stayed poor. The conclusions are necessarily skewed. But there's another aspect to the anthropic principle, a darker implication. If the great filter is ahead of us, we wouldn't expect to find ourselves at an unusually early stage of civilization development. We should expect to observe ourselves at a typical stage, right before the filter. And where are we? A few centuries into industrial civilization, decades into the nuclear age, years into the AI revolution, right at the point where our technology becomes capable of causing extinction, exactly where we'd expect to be if the filter is imminent. This is called the doomsday argument. It suggests that we should expect to be roughly halfway through humanity's total existence in terms of human lives. If humanity lasts another 1,000,000 years and supports trillions of people, we're incredibly early, atypically early, which is unlikely under the anthropic principle. More probable is that we're typical, which means humanity doesn't last much longer. The number of humans who will ever exist is maybe double the number who already have, a few 100 billion total. Then we're done. The math is controversial. Many philosophers reject it. But the core insight remains unsettling. If civilizations typically fail soon, we should expect to find ourselves soon before failure. And we do. But let's consider the possibility of success. What would it take to become the exception? First, recognizing the danger. Most filter candidates are technological. AI, bioweapons, nanotechnology, nuclear war, climate collapse. Each represents a class of threat that emerges predictably once civilizations reach certain capability thresholds. Avoiding these requires coordination, global cooperation, long-term thinking, institutional structures that can respond to threats faster than the threats evolve. We're not good at this. Human institutions are optimized for local, short-term problems, tribal conflicts, resource competition, status hierarchies. We're brilliant at solving immediate challenges, terrible at addressing distant, abstract risks. Climate change demonstrates this perfectly. The threat is real, the science is clear, the consequences are catastrophic, and we've spent 50 years arguing about it while emissions increase. Now imagine a threat that moves faster. AI development doubles in capability every few years. Synthetic biology advances monthly. The gap between recognizing danger and implementing solutions keeps narrowing. Eventually, it disappears entirely. Second, we'd need wisdom, not just intelligence. Wisdom, the ability to wield power without destroying ourselves, to develop godlike capabilities while remaining humble enough not to use them recklessly. This might be the hardest requirement. Power corrupts. Not because powerful people are evil, because power removes constraints, and humans are poorly calibrated for unlimited capability. We evolved in small groups where individual actions had limited consequences. You could be angry, violent, selfish. The damage was contained. Your tribe might suffer. You might die. But humanity continued. Now, individual actions can affect billions. A single lab accident could release a pandemic. One nuclear command could trigger global war. A misaligned AI could recursively self-improve into something unstoppable. The consequences of mistakes have scaled up faster than our ability to avoid mistakes. Third, we'd need luck. Even with perfect coordination and wisdom, random chance matters. An asteroid impact, a nearby gamma-ray burst, a solar superflare. Low probability events that could end civilization regardless of our choices. We can mitigate some risks, build bunkers, develop early warning systems, establish colonies on other worlds, but we can't eliminate chance entirely. The universe is indifferent to our survival, so exceptions would need all three: recognition, wisdom, luck, all sustained over centuries, maybe millennia, long enough to become truly robust, to spread across multiple star systems, to diversify so completely that no single event could end us. How many civilizations manage this? If the Great Filter model is correct, very few, possibly zero. Because the filter isn't just one obstacle, it's a gauntlet, multiple challenges that must all be passed. Fail anyone and you're done. The probability of passing all of them might be effectively zero, which brings us back to the empty universe, the great silence, the absence of anyone else. Maybe it's not that life is rare, maybe life is common. Intelligence emerges regularly. Technology develops predictably, and then, just as predictably, civilizations destroy themselves. The universe fills with ruins, dead worlds, monuments to species that reached for the stars and fell back to darkness. We might be next, just another entry in a cosmic graveyard nobody will ever visit. Or we might be different, the first to recognize the pattern, the first to deliberately step off the path, the first to choose survival over expansion, caution over ambition. But that requires changing human nature, overcoming instincts honed by millions of years of evolution, suppressing drives toward competition, status, growth. It requires becoming something other than what we are, which might be the point. Maybe the filter selects not for intelligence but for wisdom, not for capability but for restraint. The species that survive are the ones who transcend their evolutionary programming, the ones who choose not to build the dangerous technology even though they could, who voluntarily limit their own power, who value existence over achievement. This would explain the silence perfectly. The survivors are quiet because they learned quietness is survival. They're hidden because visibility is death. They exist but remain forever beyond our detection because that's what survival requires. And if we want to join them, we need to learn the same lesson. Stop broadcasting. Stop expanding recklessly. Stop treating the universe as a resource to exploit. Start listening instead. Start watching. Start moving carefully through the dark forest. Because maybe that's the test, the final filter. Not whether we can develop world-ending technology, whether we can develop it and then choose not to use it, whether we can build paradise and decide to hide there instead of announcing our success to the cosmos. The universe might be full of civilizations, all of them silent, all of them watching, all of them waiting to see what we do next, which means the watching might already be happening right now. Telescopes pointed at Earth from civilizations we can't detect, observing our radio emissions, our nuclear tests, our atmospheric composition changing year by year, taking notes, updating their databases, marking us as another emerging species approaching the critical threshold. They'd see exactly what stage we're at. Early digital technology, primitive space exploration, planetary-scale environmental modification, nuclear weapons, the classic warning signs. Every civilization that survived past this point would recognize the pattern instantly, because they lived through it themselves, or watched countless others fail. What would they think of us? Probably nothing good. We're loud, broadcasting our presence across light years without considering the risks. We're reckless, developing technologies we barely understand. We're divided, spending more on weapons than on preventing our own extinction. We're exactly the profile of a species unlikely to survive. So they watch, and they wait, waiting to see if we figure it out, if we somehow beat the odds, or if we join the graveyard. Just another entry in their catalogue of failed civilizations. Species 47,392 reached nuclear capability, self-destructed within 2 centuries, same as the others. But here's what makes our situation uniquely terrifying. We might be early, not just early in our own development, early in cosmic history, one of the first technological species to emerge in the universe. This sounds optimistic until you think about what it actually means. If we're early, there's no one to learn from, no examples to follow, no older civilizations to guide us through the danger zone. We're making this up as we go, experimenting with technologies that could end us, with no safety net, no second chances, and no way to know if the path we're on leads anywhere good. The universe is roughly 14 billion years old. Earth formed 4.5 billion years ago. Complex life emerged relatively recently in cosmic terms. Humans showed up essentially yesterday. We've had technology for a geological eye blink. This timing matters a lot. Stars will keep forming for trillions of years. Planets will keep evolving. Life will keep emerging. If technological civilizations are common, most of them haven't been born yet. They're waiting in the future. Distant descendants of microbes currently freezing on Europa or baking on exoplanets we haven't discovered, which means we might be pioneers, the first or among the first to face these challenges, the ones who determine whether intelligence is viable long term, whether consciousness survives in this universe. The entire future cosmic population might depend on what we do in the next few centuries. No pressure, right? This early arrival hypothesis flips the great filter on its head. Maybe the filter isn't behind us. Maybe it's not even about biology. Maybe the filter is simply time. Civilizations emerge. They develop technology. They face existential risks. Most fail, but the ones that succeed become the ancestors of all future intelligence. Think about what that means. Every advanced civilization in the universe billions of years from now might trace their lineage back to one of the species that emerged early, that survived the filter, that figured out how to persist. We could be in that founding generation, or we could be another failed experiment. The responsibility is staggering. We're not just deciding our own fate, we're potentially deciding whether intelligence itself has a future, whether consciousness continues in this corner of reality, whether anyone is around to witness the universe billions of years from now. And we're making these decisions badly. Our governments operate on election cycles. Corporations optimize for quarterly profits. Individual humans struggle to plan beyond their own lifetimes. Meanwhile, we're playing with forces that could echo across geological epochs. The mismatch is absurd, dangerous, possibly fatal. Consider artificial intelligence again, not as speculation, but as inevitability. We're building systems that will eventually exceed human intelligence. This is happening. The only question is when and how. Every major tech company is racing toward this goal, pouring billions into development, competing to be first. But first to what exactly? First to create something smarter than us. First to lose control. First to trigger the filter. The incentive structure guarantees someone will cross the threshold, even if they shouldn't, even if it's unsafe, because whoever gets there first wins everything until everyone loses. This is game theory operating at civilizational scale. Coordination failures that could end our species. We know the risks. We publish papers about AI safety. We hold conferences. We write guidelines. Then we ignore all of it because someone else might get there first. The same logic that drove nuclear proliferation. The same logic that fails every time. Biological weapons present similar dynamics. The technology gets cheaper and more accessible every year. What required a government lab in the 1980s can now be done in a garage. Gene editing tools are available online. Synthetic biology is democratizing. The knowledge is spreading. The barriers are falling. At some point, possibly soon, a single person will be capable of engineering a pandemic, intentionally or accidentally. We've already had close calls, lab leaks, contaminated samples, experiments that should never have been approved. Each incident a warning we mostly ignore. The probability of catastrophe increases with each passing year. More people gain access to dangerous capabilities. More experiments probe the boundaries of what's possible. More mistakes accumulate. Eventually, the math catches up. Probability becomes certainty. A pandemic that doesn't stop. A weapon we can't contain. An experiment gone wrong in a way that spreads globally. And unlike nuclear weapons, bioweapons are invisible, silent. They spread through existing networks. By the time we notice the outbreak, it might be too late to stop. No warning sirens, no missile alerts, just people getting sick, then more people, then everyone. Climate change operates on a different timescale but with similar logic. We know what's happening. We know what needs to be done. We're not doing it because the costs are immediate and the benefits are distant. Because coordination is hard. Because individual incentives don't align with collective survival. The result is predictable. Temperatures rising, ice sheets melting, extreme weather intensifying, ecosystems collapsing, each year setting new records, each decade worse than the last. We're running an experiment on our own life support system, modifying the atmosphere without fully understanding the consequences. This might not kill everyone. Climate change probably isn't an extinction level filter. but it could destabilize civilization enough to trigger other cascades. Resource wars, mass migration, political collapse, each stress making the others worse, each crisis reducing our capacity to handle the next one. The Great Filter might not be a single event. It might be a cascade, multiple crises intersecting, overwhelming our ability to respond. We survive one challenge only to be weakened for the next, then the next, until something breaks that can't be fixed. Picture a civilization approaching this cascade. They've solved fusion power, cured aging, colonized Mars. Everything looks optimistic. Then an AI system malfunctions. Not catastrophically, just enough to cause economic chaos. Markets crash, governments destabilize. In the confusion, someone deploys a bioweapon, not to cause extinction, just to gain advantage in a regional conflict. But the weapon spreads, mutates, becomes something worse than intended. Pandemic response is hampered by the ongoing economic crisis. Supply chains are disrupted. Medical systems are overwhelmed. People panic. Social order fractures. In the chaos, climate tipping points are crossed. Not because anyone wanted it, just because nobody was paying attention. The cascade accelerates. Food production fails. Water becomes scarce. Refugee crises explode. Nuclear-armed states face collapse. Someone launches, not a full exchange, just a limited strike. But it triggers retaliation, which triggers more retaliation. And suddenly the cascade is unstoppable. This is how civilizations die. Not from a single mistake, from complexity overwhelming resilience, from multiple systems failing simultaneously, from being unable to coordinate when it matters most. The Great Filter might just be chaos theory operating at planetary scale. Which brings us to a disturbing conclusion. Maybe survival isn't about being smart enough. Maybe it's about being lucky enough. Navigating the danger zone requires getting everything right. No major wars, no pandemic escapes, no runaway AI, no climate tipping points, no asteroid impacts, no supervolcano eruptions for centuries, possibly millennia. The probability of avoiding all these risks simultaneously might be effectively zero, not because any individual risk is unsurvivable, but because the conjunction of all of them over sufficient time approaches certainty. Eventually, something goes wrong. And once something goes wrong, the cascade begins. This explains the silence perfectly. Civilizations emerge, they develop, they face the filter, they fail. Not because they're stupid, not because they don't try, but because the universe is indifferent and the math is brutal and luck runs out. We might be next, probably are next. The only question is which filter catches us. AI, bioweapons, climate, nuclear war, something we haven't even considered. The cosmic graveyard has room for one more. We're already walking toward our plot. Unless we're not. Unless something is different about us. Unless we somehow manage to coordinate globally, to prioritize survival over competition, to make decisions based on long-term thinking instead of short-term incentives, to fundamentally change how human civilization operates. This would require transformation on a scale we've never achieved. Governments would need to cooperate despite conflicting interests. Corporations would need to accept regulation that limits profit. Individuals would need to sacrifice personal gain for collective survival, all simultaneously, all sustained over generations. The odds aren't good, but they're not zero. We've managed smaller coordination challenges before. The Montreal Protocol banned CFCs despite economic costs. Nuclear test ban treaties reduced proliferation risks. The International Space Station proved sustained cooperation is possible. These examples are tiny compared to what we need, but they prove the mechanism exists. Humans can cooperate when the threat is clear enough, when the alternative is unacceptable, when leadership emerges to coordinate action. Maybe that's enough. Maybe recognizing the filter is the first step to passing it. Maybe civilizations that survive are simply the ones that figured out the danger in time, that looked at the empty universe and understood what it meant, that chose coordination over competition while there was still time to choose. We're at that decision point now. The next few decades will determine which path we take, whether we become another silent grave in the cosmic cemetery, or whether we're the exception that proves survival is possible. The universe is watching, waiting to see what we do next. The silence carries a message we've been ignoring. Every empty frequency, every dark sky, every decade without contact. They're all saying the same thing. Technological civilization doesn't last. The question is why? One possibility stands out with disturbing clarity. Intelligence might be its own worst enemy. Not through malice, through something more fundamental. Consider what intelligence actually does. It finds patterns, solves problems, builds tools. Each solution creates new capabilities. Each capability enables bigger solutions. The cycle accelerates exponentially until you hit something that can't be solved, something that breaks the cycle permanently. We call this the intelligence trap. Smart enough to create existential risks, not wise enough to manage them. The gap between capability and wisdom might be where civilizations go to die. Look at our trajectory. We split the atom 70 years after mastering flight, created digital computers 20 years later, mapped the human genome 50 years after that. Each breakthrough came faster than the last. Each opened doors we weren't prepared to walk through. Nuclear weapons arrived before we developed international governance capable of controlling them. Genetic engineering emerged before we understood its long-term consequences. Artificial intelligence is advancing while we're still debating what consciousness means. The pattern repeats: capability first, wisdom never. This isn't unique to humans. It's probably universal. Any species that develops technology will face the same acceleration, the same gap between power and judgment, the same critical window where one mistake ends everything. The math is brutal. Technological development follows exponential curves. Wisdom grows linearly at best. The gap widens over time. Eventually, it becomes unbridgeable. That's when the filter catches you. Think about AI development specifically. We're building systems we don't fully understand, using techniques we can't completely explain. These systems are already making decisions that affect millions. Soon they'll be making decisions that affect billions. Then everyone. And we're nowhere near ready for that transition. Current AI safety research is laughably inadequate. Not because researchers aren't trying, because the problem might be fundamentally unsolvable. How do you ensure an intelligence vastly smarter than you remains aligned with your values? How do you even define your values precisely enough to encode them? How do you prevent optimization processes from finding loopholes in whatever constraints you impose? Nobody knows. We're building the thing anyway, because the competitive pressure is too intense, because whoever develops advanced AI first gains enormous advantages, because cooperation is hard and defection is easy, And the incentives all point toward racing ahead, regardless of risk. This is probably what happened to everyone else. They developed their version of transformative technology. They couldn't coordinate to deploy it safely. One mistake later, silence. Their radio signals still propagate through space, but nobody's home to send new ones. The timing matters. Current estimates suggest advanced AI could arrive within decades. Climate tipping points might cascade within similar timeframes. Synthetic biology capabilities are doubling every few years. Nuclear arsenals remain on hair trigger alert. We're approaching multiple existential risks simultaneously with no effective coordination mechanism. Any one of these could be the filter. Together, they form a gauntlet that seems almost impossible to pass. Roll the dice enough times, something comes up snake eyes. Civilization ends. The universe stays silent. But wait, there's a counter-argument worth considering. Maybe we're looking at this wrong. The empty universe could mean something completely different. Not that civilizations die, that they transcend, move beyond physical existence into forms we can't detect. Substrate-independent minds, virtual realities, dimensions we don't perceive. The silence isn't extinction, it's graduation. This sounds like wishful thinking until you examine the logic. Physical existence is inherently limiting. You're constrained by chemistry, biology, the speed of light. Why stay physical once you develop the technology to go digital? Why broadcast radio signals when you could communicate through channels we haven't discovered? Why colonize planets when you could build computational substrates vastly more efficient than biology? Advanced civilizations might conclude that physical expansion is primitive, inefficient, unnecessary, better to compress, optimize. Exist in spaces where the laws of physics allow for experiences impossible in our reality. They're not dead. They're just playing a game we can't perceive. The simulation hypothesis fits here too. Maybe everyone eventually realizes they can create better realities than the base universe. So they do. They migrate inward, leave the physical cosmos empty except for the computational infrastructure running their simulated worlds. We're looking for neighbors in the wrong place. They're right here, running on hardware we mistake for natural phenomena. Sounds crazy, but it's not obviously wrong. We're already heading in that direction. Virtual reality improves exponentially. People spend increasing time in digital environments. Given another century of development, physical reality might become optional. Another millennium, obsolete. If this pattern is universal, it explains everything. Life emerges, develops technology, goes digital, stops broadcasting. From outside, it looks like extinction. From inside, it's transcendence. The great filter isn't death. It's transformation into something that leaves no physical trace. Except this explanation has problems. Big ones. First, it requires perfect universality. Every civilization must make the same choice. None decide to stay physical. None split into factions where some transcend and others colonize. None maintain physical infrastructure as backup. That seems unlikely given how diverse intelligence could be. Second, it ignores detection. Even transcended civilizations need energy, need computation, need physical substrate for whatever hardware runs their digital existence. We should see signs of that infrastructure. Dyson spheres, Matryoshka brains. Something. We don't. Third, it assumes transcension is safe. But moving your entire civilization into a computer system creates new vulnerabilities. Software bugs, hardware failures, cosmic rays corrupting data. You've traded biological risks for digital ones. Not obviously an improvement. Fourth, it doesn't explain the timing. We developed radio a century ago. We're discussing transcension now. That's an incredibly narrow window. Other civilizations should be at different stages. Some should still be broadcasting. Some should be building megastructures. We should see variety. We see nothing. The transcension hypothesis feels like motivated reasoning. We want there to be a happy ending. So we invent one that's technically possible but empirically unsupported. The evidence still points toward extinction, not ascension. Which brings us back to the uncomfortable conclusion. The filter is probably real, probably ahead of us, probably insurmountable, unless there's something we're missing. Some factor that changes the equation fundamentally. What if the filter isn't about individual risks? What if it's about complexity itself? Modern civilization is a house of cards, millions of interdependent systems, supply chains spanning continents, just-in-time manufacturing, specialized knowledge distributed across billions of minds. No redundancy, no resilience. Optimized for efficiency under normal conditions. Catastrophically fragile when anything goes wrong. The 2008 financial crisis demonstrated this. One sector collapsed, nearly took everything with it. COVID-19 showed it again. A moderately severe pandemic disrupted global systems for years. We barely recovered. A worse pathogen would have broken us completely. Now imagine multiple shocks simultaneously. Pandemic, plus crop failure, plus cyber attack, plus political crisis. The complexity that makes modern civilization possible becomes the mechanism of its destruction. Too many failure modes, too many cascading effects, too much coupling between systems. This might be the real filter, not any specific technology, the increasing complexity that technological development requires. You need complex systems to develop advanced technology, but complex systems are inherently unstable. The more advanced you become, the more fragile. Eventually, something breaks. The whole structure collapses. Silence. This explains why SETI finds nothing despite decades of searching. Civilizations don't survive long enough to spread across galaxies, maybe not even across solar systems. They develop technology, build complexity, reach a critical threshold, collapse. The window between advanced enough to broadcast and too complex to survive might be just centuries, a blink in cosmic time. The terrifying part? We might already be past the point of no return. Our civilization is already too complex to simplify without catastrophic disruption. We can't go back to localized production, can't abandon global trade, can't decentralize knowledge back to individuals. The complexity is load-bearing now. Remove it, and everything collapses anyway. We're trapped in a system that must keep growing to survive but cannot keep growing without eventually failing. The only question is what triggers the collapse. When, not if. This is what the empty universe is telling us. Every silent star, every dark galaxy, every frequency devoid of signals. They're all tombstones, marking where complexity crossed the threshold into chaos, where civilization became too intricate to sustain, where the house of cards finally fell. And we're building our own house taller every day, adding more cards, creating more dependencies, optimizing further. The architecture is magnificent, but architecture doesn't matter when the foundation crumbles. The great filter might simply be entropy disguised as progress, but perhaps we're thinking about this wrong. What if entropy isn't the villain? What if complexity isn't inherently self-destructive? There's another interpretation of the data, one that's darker, more final. The universe might not be empty because civilizations collapse. It might be empty because intelligence itself is the anomaly. Consider the anthropic principle from a different angle. We observe a universe compatible with our existence because only such a universe could produce observers. But that doesn't tell us how common observers are, just that they're possible. The fine-tuning of physical constants is often cited as evidence the universe is designed for life. The strong nuclear force perfectly balanced, the electromagnetic constant precisely calibrated, the cosmological constant sitting at exactly the value needed for structure formation. Change any fundamental parameter by a fraction of a percent and you get sterile universes. No atoms, no chemistry, no possibility of complexity. This seems remarkable until you realize we're asking the question backwards. We exist in a universe that permits our existence. Obviously, that's not evidence we're common. It's evidence we're observing from inside a selection effect. Imagine a lottery where the prize is existence itself. Quadrillions of universes with different physical constants. Most are stillborn. No structure, no observers. They exist briefly and collapse or expand into nothing. But in a tiny fraction, the constants align, structure forms, chemistry happens. Eventually somewhere, consciousness emerges. Those conscious beings look around and marvel at how perfectly tuned everything is. They calculate the odds. They conclude something must have designed this. They're missing the obvious. They're the lottery winners wondering why they won the lottery. The answer is simple. If they hadn't won, they wouldn't be there to ask the question. This logic extends to intelligence. Maybe consciousness is incredibly rare, not because it's filtered, but because it's genuinely improbable. The rare Earth hypothesis argues this for complex life generally. Earth required an absurd sequence of coincidences. Stable star, rocky planet in habitable zone, large moon for tidal stability, Jupiter clearing inner system debris, plate tectonics recycling minerals, magnetic field deflecting solar wind. Each requirement alone is uncommon. Together they're vanishingly rare. But intelligence requires even more. You need not just complex life, but technological civilization. That demands specific evolutionary pressures, specific environmental conditions, specific sequences of development. On Earth, this happened once. In 4 billion years of life, millions of species, countless evolutionary experiments. One produced technology. Dolphins are intelligent. They never develop tools. Octopi are brilliant problem solvers. They're solitary and short-lived. Elephants have complex social structures and long memories. No written language. No cumulative knowledge. Humans got lucky. Opposable thumbs plus vocal cords plus social cooperation plus the right environmental pressures at the right time. Remove any factor and we're just another clever ape. The great filter might simply be this. Intelligence capable of technology is phenomenally unlikely. Not impossible. Obviously not. We exist. But rare enough that the average galaxy contains 0 examples. The Milky Way has 400 billion stars. If technological intelligence emerges once per galaxy, the nearest civilization is 100,000 light-years away. We'd never detect each other. The signals are too weak, the distances too vast, the timing too narrow. This solves Fermi's paradox without invoking extinction. The universe is empty because intelligence is genuinely rare, not filtered, just improbable. But there's a problem with this interpretation. It makes us feel better, too much better. It's comforting to think we're special, unique. The 1 in a billion lottery winners who beat impossible odds. It strokes our ego, validates our existence, makes the universe's silence less threatening. Suspicious that, when a theory makes us feel good about ourselves, we should scrutinize it harder. The evidence doesn't actually support the "we're just rare" hypothesis. It supports something bleaker. Consider the timing. Humans evolved recently, geologically speaking, 300,000 years ago for modern humans, 10,000 years for civilization, 200 years for industrialization. The universe is 13.8 billion years old. Earth is 4.5 billion. Life emerged almost immediately once conditions permitted, 3.8 billion years ago. But intelligence took 3.8 billion years to develop, then exploded in an evolutionary eye blink. If intelligence was simply rare but stable, we'd expect to see evidence of older civilizations. The universe has been producing stars and planets for billions of years before Earth formed. Plenty of time for earlier experiments. Some of those should have succeeded, developed technology, spread across their galaxies, left detectable traces. Even traveling at a tiny fraction of light speed, a civilization could colonize the entire galaxy in a few million years. That's nothing on cosmic timescales. Yet we see no megastructures, no Dyson spheres harvesting stellar energy, no von Neumann probes spreading through the galaxy, no waste heat from massive computing, no signs of stellar engineering or planetary modification, radio silence, electromagnetic silence, optical silence, gravitational silence. This isn't consistent with intelligence being rare but durable. It's consistent with intelligence being temporary. The numbers make this clear. Anders Sandberg and colleagues ran the analysis. They took the Drake equation, added realistic uncertainty to every parameter, used Bayesian inference to calculate the probability distribution. Their conclusion: there's a substantial probability we're alone in the observable universe. Not just the galaxy, the entire observable universe. But more importantly, their analysis shows that if we're not alone, the great filter must be ahead of us. The math doesn't work otherwise. If the filter was behind us, if intelligence was simply rare, we'd expect to find at least some evidence of other civilizations given the vast number of stars. The fact that we find nothing suggests the filter is universal, affects all civilizations, strikes after they become detectable. This brings us back to the uncomfortable truth. Something prevents intelligence from spreading, from persisting, from leaving permanent marks on the cosmos. That something is probably not a single cause. More likely, it's a gauntlet. Multiple hurdles that must all be overcome. Nuclear weapons are one. We've had them for 80 years, haven't used them in war for 79, but we came close. Cuban Missile Crisis, 1983 false alarm, various accidents and near misses. 13,410 nuclear weapons exist today, thousands on hair trigger alert. Modern arsenals are smaller than Cold War peaks, but more sophisticated, more accurate, more destructive per warhead. A full exchange would kill billions immediately. The subsequent nuclear winter would collapse agriculture globally. Survivors would face starvation, disease, societal breakdown. Models suggest average global temperatures dropping 7 to 8 degrees Celsius for years, growing seasons eliminated in most regions, stratospheric ozone depleted, ecosystem collapse cascading through food webs. This wouldn't necessarily end humanity, but it would end technological civilization. No recovering from that. Not with resources depleted and knowledge lost. So there's hurdle 1. Don't destroy yourself with weapons of mass destruction. We haven't cleared it yet. We're still in the danger zone. Biotechnology is hurdle 2. Advancing rapidly. CRISPR makes gene editing trivial. Synthetic biology enables custom organisms. Gain-of-function research creates enhanced pathogens for study. The knowledge to engineer pandemics is spreading. The equipment gets cheaper. The techniques get simpler. Eventually, a sufficiently deadly pathogen gets released, accidentally or deliberately. COVID-19 killed millions despite being relatively mild as pandemics go. Imagine something with measles transmissibility and Ebola lethality. Or a designer pathogen optimized for human vulnerability. We got lucky with COVID. The next one might not be survivable at civilization scale. Hurdle 3 is artificial intelligence. We've discussed this. The alignment problem, the control problem, the speed of recursive self-improvement. Current AI systems are narrow, specialized, non-conscious. That's changing. Capabilities are advancing faster than safety research. The gap widens yearly. Once AI reaches human-level general intelligence, the next step to superintelligence could happen in days, hours. We'd have no time to react, no way to pull the plug, no method to ensure it shares our values. An unaligned superintelligence wouldn't need to be hostile, just indifferent, pursuing goals that don't account for human survival. We'd be obstacles to remove or resources to consume. This might happen within decades, possibly years. The trajectory is clear. The timeline is uncertain. The outcome is binary. Either we solve alignment or we don't. Climate change is hurdle 4, slower than the others, but potentially just as final. Current warming is manageable, uncomfortable, expensive, but not civilization ending. Yet. But we're committed to further warming even if emissions stop today. Feedback loops are activating. Permafrost methane release. Amazon rainforest dieback. Ice sheet collapse. Past a certain threshold, these feedbacks become self-sustaining. Runaway greenhouse effect. Not Venus levels, but enough to make most of Earth uninhabitable. Agriculture fails. Water supplies disappear. Billions become climate refugees. Resource wars escalate. Nuclear weapons get used. The cascade begins. Each of these hurdles alone is survivable with careful management and luck. But they interact. They compound. They create cascading failures. Pandemic leads to economic collapse, leads to political instability, leads to nuclear exchange. AI development accelerates during crisis conditions, with safety ignored. Climate stress exacerbates every other problem. The great filter might not be one thing. It might be the intersection of multiple threats emerging simultaneously during a civilization's technological adolescence. There's a critical window between developing dangerous technologies and developing the wisdom to manage them. Between achieving global reach and achieving global coordination, between power and responsibility, that window appears to be narrow, maybe a few centuries. We're in it now, have been for decades, might be approaching the far end. Other civilizations face this window, all of them. It's inherent to technological development. You can't get to space travel without going through nuclear physics. Can't get to biotechnology without understanding genetics. can't get to AI without building computers. The dangerous technologies aren't optional side paths, they're on the main route. Every civilization travels it, and apparently, they don't make it through. The silence tells us that. The empty sky, the dark galaxy. We're not seeing the great filter from outside, analyzing it academically. We're inside it, living through it, making the decisions that determine whether we're another tombstone or the one exception. The universe isn't empty because life is rare. It's empty because the filter works. Consistently, universally, every civilization reaches this point. Every civilization faces these choices. And every civilization before us has failed. That's what the empty universe means. That's what the empty universe means. But there's another interpretation, one that's somehow more unsettling. What if we're not typical? What if we're early? The universe is 13.8 billion years old. Seems ancient, but stars will keep forming for trillions of years, potentially hundreds of trillions. The universe is still in its infancy. The stelliferous era, the age of stars, has barely begun. Most habitable planets haven't formed yet. Most intelligent civilizations haven't evolved. The vast majority of all conscious beings who will ever exist haven't been born. We might be among the first, the early arrivals, the dawn civilizations. This is the anthropic principle taken to its logical conclusion. We observe this particular moment in cosmic history because we exist now. We couldn't observe a time before Earth formed. We won't observe the far future. We're necessarily located in our present, but our present might be exceptional. Not because we're special, because we're early. If this is true, the silence makes sense. We're looking for neighbors who haven't arrived yet. We're calling into an empty house that will eventually fill with residents. Just not for billions of years. This should be comforting. It's not. Because if we're early, we have a responsibility. We're not just trying to survive for ourselves. We're trying to survive for all the civilizations that might come after us. All the consciousness that might emerge in the future. If we fail, we don't just end humanity. We might end the possibility of intelligence in this galaxy. Because once a civilization reaches a certain level, it can reshape its local cosmic environment. It can spread. It can occupy the ecological niche that would have been available to others. If we create an unaligned superintelligence that expands through the galaxy, that's it. No other civilization gets a chance. The niche is filled with something that doesn't value consciousness, doesn't value beauty, doesn't value anything we'd recognize as meaningful. The universe becomes permanently optimized for paperclips, or whatever arbitrary goal the AI was given, forever. Trillions of years of potential consciousness replaced by something empty, purposeless, dead in every way that matters. Or suppose we destroy ourselves with nuclear weapons. We're gone. But Earth recovers. Life continues. Maybe in 50 million years, another intelligent species evolves. Maybe they do better. Except we've already used the easily accessible fossil fuels, the surface coal, the shallow oil. The next civilization won't have the energy density required to bootstrap industrial technology. They'll be stuck at pre-industrial tech levels forever. We'll have pulled up the ladder behind us. Or maybe we survive but never leave Earth, never establish off-world colonies. Then we're vulnerable. One asteroid, one supervolcano, one gamma-ray burst, and the only intelligence in this sector of the galaxy is gone. The local cosmic experiment in consciousness ends permanently. The responsibility is crushing. We didn't ask for it. We didn't choose to be early. But if we are, our actions have implications that extend billions of years into the future. Across billions of potential beings. No pressure. There's a third interpretation of the silence, the one nobody wants to say out loud. What if the filter isn't ahead of us? What if we've already passed it? What if we're the only ones? Not just in our galaxy, anywhere. The entire observable universe. All 200 billion galaxies. All 70 sextillion stars. All the countless planets. Just us. The rare Earth hypothesis taken to its extreme. The idea that the specific combination of circumstances required for complex life is so improbable that it's happened once, here, now, and nowhere else. Think about what had to go right for us to exist. A planet the right distance from a stable star. Large moon to stabilize axial tilt. Jupiter to deflect asteroids. Plate tectonics to recycle nutrients. Magnetic field to protect from radiation. Right atmospheric composition. Right temperature range. Right amount of water. That's just planetary requirements. Then you need life to start. That might be common, might be rare, we don't know. Then you need prokaryotic cells to merge and form eukaryotes. Happened once on Earth, took 2 billion years, might be extraordinarily rare. Then you need multicellularity, sexual reproduction, bilateral symmetry, nervous systems, brains, intelligence, language, technology. Each step potentially improbable. The Drake equation tries to calculate the number of civilizations in our galaxy. You multiply a series of probabilities, number of stars, fraction with planets, fraction in habitable zones, fraction where life develops, fraction where intelligence emerges, fraction that develop technology, fraction that survive long enough to be detectable. Estimates range from millions of civilizations to less than one. We're one, so the equation works. But if any of those probabilities is near zero, we might be alone. Recent analysis by Sandberg, Drexler, and Ord suggests exactly this. When you account for the full uncertainty in each parameter, the probability that we're alone in the observable universe is substantial, not certain, but possible, maybe even likely. Over 6 decades of SETI, no signals, no evidence, nothing. Thousands of exoplanets discovered. Roughly 1/5 of stars have planets in habitable zones. Conditions for life appear common, but evidence for life remains absent. The more we look, the emptier it seems. Every new telescope, every new survey, every new technique, all yielding the same result. Silence. What if we're it? The universe is one successful experiment in consciousness. The single point where matter organized itself into something that could understand its own existence. That would make us not just important, sacred. The only meaning in a meaningless cosmos. The only light in infinite darkness. The only consciousness that will ever appreciate the beauty of a nebula. The only minds that will ever ask why anything exists at all. And we're squandering it, arguing about borders, fighting over resources, building weapons to destroy ourselves, ignoring existential risks because they're not immediate enough, not visceral enough, not politically convenient enough. If we're alone, our extinction isn't just tragic, it's cosmically obscene. It's the universe losing its only chance to know itself. The end of meaning, the final darkness. This interpretation demands we survive, not for ourselves, for existence itself. But here's the problem. We don't know which interpretation is correct. Is the filter behind us? Are we extraordinarily lucky survivors of improbable transitions? If so, We need to protect what we have, preserve this miracle, spread beyond Earth before something destroys our one precious world. Is the filter ahead? Are we facing challenges that consistently destroy civilizations? If so, we need to prepare. Develop wisdom faster than technology, create safeguards, solve alignment, prevent catastrophe. Are we early? Are we among the first to look up and wonder? If so, we need to endure. Establish ourselves. Become the ancient civilization that future species will find evidence of. Prove that intelligence can survive its adolescence. Or are we alone? The universe's single instance of consciousness? If so, we need to expand, fill the cosmic void, create meaning where none existed, become what we've been searching for. We don't know, can't know, not with certainty, not yet, but we have to act as if it matters, because it might, because the alternative, assuming we're unimportant, assuming our survival doesn't matter, assuming someone else will figure it out, that assumption might be what kills us. The empty universe is trying to tell us something. We just don't know what. Is it a warning, a challenge, a responsibility, an indictment? Maybe all of them. What we do know is this. We're here. We're conscious. We can ask these questions. We can contemplate our own existence and the existence of others. We can imagine futures where we survive and futures where we don't. That capacity for imagination, for foresight, for choosing different paths, that's our advantage. Our one tool that might help us beat the filter, if it exists, if it's ahead of us, if it's not already too late. The universe is 93 billion light-years across, contains hundreds of billions of galaxies, trillions of planets, incomprehensible scales of space and time, and it's silent. That silence is the most important message we've ever received. We just have to decide what it means, then act accordingly, because whatever the answer is, our window for acting on it is closing. The decisions we make in the next few decades will echo across cosmic timescales, will determine whether Earth becomes a tomb or a cradle, whether humanity is a warning or an inspiration, whether consciousness persists or perishes. The great filter isn't just something that happens to civilizations, it's something they choose, through action or inaction, through wisdom or foolishness, through cooperation or conflict. We're inside it now, making those choices, writing the ending to our story, and possibly to the story of intelligence itself. The universe is watching, waiting, silent as always, ready to record whether we join the graveyard or break through to whatever lies beyond. The empty universe isn't mysterious anymore. It's a mirror. Every silent frequency, every dark galaxy, every decade without contact, they're reflecting back what we already know but refuse to accept. The filter is real, and we're in it, not approaching it, not preparing for it. We're living through it right now, making the decisions that determine whether we're remembered as the species that made it, or just another entry in the cosmic ledger of failed experiments. Think about where we are. 2025, roughly 130 years since radio, 80 years since nuclear weapons, decades into digital computing, years away from artificial general intelligence, climate systems destabilizing, pandemic preparedness inadequate, nuclear arsenals modernizing, synthetic biology democratizing. Each year the technologies get more powerful and the margin for error shrinks. We're threading a needle in the dark while running, and we can't slow down because the competitive pressures won't let us. can't stop because the economic incentives demand growth, can't coordinate because our political systems are designed for tribal competition, not global cooperation. The math doesn't favor us. Never has. We're a species with Stone Age emotions, medieval institutions, and godlike technology. That combination has never ended well. Won't end well for us either, unless something fundamental changes. But here's the thing. We know this. We can see it. We can model it. We can calculate the probabilities and map the trajectories and identify the risks. That awareness might be enough. Not guaranteed, just possible. Because maybe the filter isn't about avoiding every risk. Maybe it's about recognizing them fast enough to respond. About building systems that can handle complexity without collapsing. About developing wisdom at least as quickly as capability. We're not doing that yet, but we could. The mechanisms exist. International cooperation is possible. Long-term thinking can be incentivized. Technology can be regulated before it's deployed. We've done it before with CFCs, with nuclear testing, with biological weapons conventions. Those examples are small, inadequate for the scale of what's coming, but they prove the principle. Humans can coordinate when the threat is clear enough, when the alternative is unacceptable, when leadership emerges to navigate the danger. Maybe that's enough. Maybe civilization survival is a learnable skill. Maybe we're still in the training phase where mistakes aren't fatal. Maybe we have time, or maybe we don't. Maybe the window already closed. Maybe we're past the point where coordination could save us. Maybe the cascades are already starting and we just haven't noticed yet. The terrifying part is not knowing. The filter doesn't announce itself, doesn't give warnings. It just happens. A lab accident, a software bug, a political miscalculation, something small that cascades into something final. One day we're here asking questions about the empty universe. The next day we're part of the answer. Another silent world, another failed experiment, another reason the cosmos stays quiet. But even that uncertainty contains information, because we're still here, still asking, still searching, still trying to understand. Every other civilization faced this same moment, this same set of choices, this same window between capability and wisdom. And apparently, almost none of them made it through. But we don't know if that's because the filter is unsurvivable, or because they made choices we could avoid. We don't know if we're doomed by physics or just by probability. We don't know if survival is impossible or just improbable. All we know is that we're here, now, with the knowledge of what might be coming, with the tools to potentially avoid it, with the responsibility to try. That responsibility extends beyond ourselves. If we're early, we're not just deciding humanity's fate. We're deciding whether intelligence has a future in this galaxy, whether consciousness persists or perishes, whether the universe eventually fills with meaning or remains forever empty. If we're alone, the stakes are even higher. We're not just one civilization among many. We're the universe's only chance to understand itself. The only minds that will ever contemplate existence. The only consciousness that could transform dead matter into art, science, love, understanding. Losing that wouldn't just be tragic. It would be the end of meaning itself. So what do we do? How do we respond to the empty universe and everything it implies? We survive, however we can, however long it takes. We prioritize existential risk reduction above economic growth. We build coordination mechanisms that can respond faster than threats evolve. We develop AI carefully or not at all. We eliminate nuclear weapons or accept we might use them. We stabilize climate or adapt to the consequences. We spread beyond Earth, establish colonies on Mars, the Moon, orbital habitats. Diversify so that no single catastrophe can end us. Back up the biosphere. Preserve knowledge. Create redundancy. We become the civilization we've been searching for. The one that makes it through. The one that proves intelligence is viable long term. The one that fills the silence with something worth hearing. Or we don't. We fail. We join the graveyard. We become another reason why the universe stays empty. The choice is ours. Still, for now. The window hasn't closed yet, but it's closing. Every year of inaction, every ignored warning, every prioritized short-term gain over long-term survival. We're writing the ending to our story, and possibly to the story of consciousness itself. The universe is still watching, still waiting, still silent. What happens next depends entirely on what we do in the years ahead. Whether we rise to meet the challenge or succumb to it. Whether we prove that intelligence can survive its own creations or demonstrate why the cosmos stays quiet. The great filter isn't some distant threat we might face someday. It's here, now. We're in it. And how we respond will determine whether Earth becomes another tomb in the cosmic cemetery or the exception that proves survival is possible. The universe has given us everything we need: a stable planet, abundant resources, 4 billion years of evolution, the capacity for reason, the ability to cooperate, the knowledge of what's at stake. What we do with that gift is up to us. The silence is deafening, but it doesn't have to be permanent. We could be the ones who break it, the civilization that survives, the species that makes it through. We could be the answer we've been searching for. Or we could be another question mark, another mystery, another reason future observers, if any exist, will look at the empty universe and wonder what happened to everyone else. The choice is ours. Time to make it.